Hello everyone, I'm Adam and this is Go To Coders. Today we're going to be talking about why are video game loading bars so inaccurate. I'm excited to talk about my experience with resource loading. Let's get started. Hoo-yah! So during my career in the game industry, one thing that became very apparent to me was that resource loading happened in such a way that it was nearly impossible to give an accurate loading bar. And I want to explain two ways that I've seen it done in different game engines, and then talk about why you may get loading bars that, for example, are moving along really fast and then stop. And then that loading bar sits there for a while, and then it moves a little bit more and then it stops. Why can't someone make a loading bar that just moves slowly across at an equal speed all the way across? So the first example that I'm going to give you will explain that one in a little bit more detail. So in the simplest form of resource management, what ends up happening is you end up with an unordered list of resources that need to be loaded for, let's say, a map. Say you're loading into a map or a scene for the very first time. This isn't traditionally done in some of the more complex video games, but I just want to break it down into the simplest solution possible so you can kind of get an understanding. So you have a series, and I'll put up some information about linked lists, but let's just say that we've got a linked list full of assets. So we have an asset here, and then in the very next node we have another asset, and the very next node we have another asset. So no hierarchy at all. We are loading a texture, we are loading a mesh, we are loading a sound file, we are loading something else. We may know the total number of assets in a map or scene in a configuration like this. This isn't completely optimal, but we may know that there are 800 items in that scene. Because resource management is built in such a way that it doesn't really care about the gameplay aspect of it. It doesn't care about what it's loading. It just knows that it needs to load something. So resource management is usually a facility that's built into the engine and has no correlation to the actual gameplay that's being loaded. So let's say we load a boot. We load a boot asset. That boot asset also needs a boot texture. Then we end up loading maybe the player's shirt, for example. Maybe he's got a skin that needs to be loaded. But we do that for a while. We're loading a lot of very small assets, so they're loading really quick. All of a sudden, we get to a massive model. Maybe it's the model of like the city of Manhattan, for example. And this ends up taking a significant amount of time. And what ends up happening here is that's when the loading bar is cruising along and then it just stops. And it feels like you're waiting forever for it to start cruising along again. Because in this resource management scheme, we know the total number of things that are being loaded. This is an overly simple explanation of this type of loading and resource management, but I think that gives you the general idea when I start talking to some of the more modern types. All right, now I'm going to talk about one that's one of my favorite, and a lot of the engines that I worked in were like this. So for example, when you're working in an engine, you may not know how to even display accurate information to a user for loading, for example, because of the way resource management is handled. And I'm going to just give you an example of that, and then we'll get into more detail. So typically we used to start with, in a simple concept, the map. Sometimes the map would have submaps in it. So let's just say that we've got a unit of data that needs to be loaded in. Maybe it's a section that is being loaded inside of an existing map, or this is a smaller game and this is an entire map loading in. This map is the top level hierarchy of a tree structure and this tree structure, or sometimes you can think of it, depending on the way they do it, as like a directed graph. Some do it with a tree structure, some do it with a directed graph. It really depends on the engine you're working with. But basically the principle I'm going to talk about here is the same. So that map might resource reference three major things. And each of those three major things might reference additional things. And then those might reference additional things and additional things. So what ends up happening is the map loads, we start loading all of its children. So we grab the player. To really be able to load the player, what we end up doing a lot of times is we need to load all of its sub things. So we end up working down this directed graph or tree structure to load everything into the application that's running. So what ends up happening is, if you ever played a game where all of a sudden you just get a loading screen and it's just a spinning circle, and you're like, I would love to have some indication of how well we're doing. The problem with that is, like, when you're building it with this hierarchy structure, the resource management literally has no idea how much stuff is loading. This thing could reference nothing, and it could be very fast. This thing could reference everything, and it could take forever. So when people try to fake loading bars, what a lot of times you will see, and I've seen this in a lot of, like, if I had to guess, I see this in a lot of, like, Blizzard games, for example, where what you will see end up happening is you'll have a loading bar, and it'll start like super small. And then what'll end up happening is all of a sudden it'll jump over to halfway. It isn't a smooth transition. Maybe they have it animated a little bit. And then it sits there for a while. And that time, depending on your computer and whatever not, may take more or less time. And then it may or may not, like, jump over here to the end and then just slowly animate to the end. I like to call those as like, those are like fake loading bars. They're only giving you a little bit of visual cue, knowing that we think we are halfway through the hierarchy here because we hit the halfway point. But in reality, they might not be, because all the big stuff could be on the other side of the tree that hasn't been allocated yet. So these are what I call like fake loading bars, but that's one of the reasons for it, is you just have no idea what you're loading. A designer comes in and he adds another asset right here. That asset might reference a ton of stuff. So now the resource manager has to load that additional things on the right side of this directed graph. One interesting thing that I want to point out as well is it actually gets really interesting in these scenarios when, like, let's say this is a cat. Let's say that there's a player and a cat. If for some reason in the hierarchy we have referenced the cat already, so maybe like the player actually has a cat reference over here, this cat will load over here, and then when we get over here, the resource manager should have already said, cat's already loaded, we're just going to give a reference to that specific object right there. So sometimes you load a lot of the heavy stuff first, and then a lot of these things are like, oh, we already have that in memory, that's already off a disk, for example. Finally, I have to say, like, at the end of the day, loading bars really are just a way to make sure that the user knows something's happening. So if you're building a game, don't feel like you need to be 100% accurate, because first off, you don't know how fast their computer is going to be. Second off, if you're building a really good resource management system and you're separating it from your game logic the way you should be, you're not going to necessarily have the information you need to provide the user with a completely accurate resource system. Because one, you don't know the time it's going to take to load that on that specific system. And two, in this scenario, you don't know the total number of items that are being referenced in this holistic view of this map, for example. Anyway, guys, I had a blast thinking about resource management again. And again, I've used so many different types of resource management due to the engine that's actually being used. And some run into some really interesting problems depending on the platform you're running on. But overall, every one that I've ever used has been inaccurate across every engine. And I'm talking major engines that are powering major games today. I hope you guys have enjoyed, and I hope you found this valuable. If you did, please give me a thumbs up. Leave a comment below if you have any additional comments or information you want to provide to everyone. And until next time, keep coding.